Alright, so this video is going to be doing some practice on telescoping sums. Okay, so we have this series up on the board here. We have the sum from n equals 2 to infinity of 2 over n squared minus 1. And we want to write out this series as a telescoping sum and then find the sum if it is convergent. Okay, so the first thing that we need to do, okay, with a telescoping sum, generally we have two terms, okay, and you can see that we can Alright, so in this video we're going to be doing some practice with telescoping sums. So we have this series up on the board. We have the sum from n equals 2 to infinity of 2 over n squared minus 1. And we want to write this out as a telescoping sum and find that sum if it is convergent. Okay, so the first step here, we can break this fraction apart using a partial fraction decomposition. Okay, and it's kind of half as hard as what we had to do with all our different techniques of integration when we had to do that partial fraction decomposition, because then we had to do integrals afterwards. But here, all we have to do is, well, we can separate that into n plus 1 and minus 1. Okay, so we get a over n plus 1 plus a b over n minus 1. Okay, and that's going to be equal to a 2 over n squared minus 1. Now, to get these common denominators right now, we have to multiply this by an n minus 1 over an n minus 1. We multiply this by n plus 1 over n plus 1. So we end up getting, we can cancel out all these denominators now and get that 2 equals a times n minus 1 plus b times n plus 1. Okay, we can just do a little bit of distribution here. We get 2 is equal to an minus a plus bn plus b. We can combine like terms here to get 2 equals a plus b times n minus a plus b. From this, we know that, well, since there is no n term on the other side, that a plus b must equal 0. Since there is a 2 on the other side, right, there's just that one constant term, and we have negative a plus b on the other side, being our constant terms, we know that negative a plus b equals 2. We get a 2b equals 2, divided by 2 on both sides. We get b equals 1, meaning that a would need to equal negative 1. And now we can write out our partial fractions up here at the top. Okay, so we get the sum from n equals 2 to infinity of, we have first a over n plus 1, kind of hard to see because I did a bunch of stuff to it, but this will be a negative 1 over n plus 1. And we have a b over n minus 1, that's just going to be a plus 1 over n minus 1. Okay, so now we can write out our partial sums, and then hopefully we have a bunch of stuff canceling out. It becomes a telescoping sum. Okay, so first we'll write out our first term, which is going to be n equals 2. Okay, so that's going to end up being negative 1 over 2 plus 1 plus a 1 over 2 minus 1. So it'll be plus a negative 1 over 3 plus 1 plus a 1 over 3 minus 1. And we keep going here. Negative 1 over 4 plus 1 plus a 1 over 4 minus 1 plus a negative 1 over 5 plus 1 plus a 1 over 5 minus 1. And then we'll go on, and we can do our ends in a little bit. All right, well, if we are to simplify this 2 plus 1, that becomes a 3, 2 minus 1 becomes a 1, 3 plus 1 becomes a 4, 3 minus 1 becomes a 2, 4 plus 1 becomes a 5, 4 minus 1, 3, 5 plus 1, 6, and 5 minus 1, 4. Okay, so we do start to see that telescoping sum here. This negative 1/3 cancels out with this positive 1/3. And this negative 1/4 cancels out with this positive 1/4. Okay? Notice how this 1 over 1 and 1 over 2 are left untouched. And the reason for that is that you would see if there was any terms before this, which can't happen because we would get a 1 over 0, then maybe you would get something that cancels out the 1 over 1 or 1 over 2, okay? But there is none at this point, okay, because that would have happened before it. But we're starting at n equals 2, so those two are going to stay. Now, this negative 1/5 and this negative 1/6, well, they'll get canceled out later on, okay, by a positive 1/5 and a positive 1/6. So they'll go away, okay? Now, since you see that we have a negative 1/3 here, and we have to go another 2 terms over to get that positive 1/3, we're going to be a little extra cautious here and with our ends, and we will just start off with a negative 1 over n plus 2 in parentheses, okay? And we'll do a plus 1 on the outside, okay? So we'll start off with, n minus 2. Okay, we'll start off with the n minus 2. So we'll start off with 2 terms lower than our actual n. This will be plus 1 over n minus 2 minus 1. And you'll see why we do this in a little bit. This is going to be plus a negative 1 over, now we go up a term to n minus 1, plus 1. This will be plus a 1 over n minus 1, minus 1. So it'll be plus a negative 1 over n plus 1, plus a 1 over n minus 1. Alright, and if we just do a little bit of simplification here, this is a n minus 2. This is just going to be an n. This will be a n minus 1. And this will be an n minus 3. Alright, now these positive terms, okay, these positive terms are the ones canceling out the negative terms beforehand. So we know that this is going to cancel out something before it, okay? This negative 1 over n plus 1 is going to cancel out this plus 1 over n minus 1. By the same reason that we cancel out the 1 over n minus 3, this 1 over n minus 2 will be canceled out. And we're left with these 2 terms here, and you can kind of think about it. You can kind of think about it to yourself if you're not sure why these stay, but these will also stay just like the 1 over 1 and the 1 over 2. Okay? Because this 1 over n minus 1, the 1 over n minus 2, the 1 over n minus 3, they're all being canceled out by terms that came before it. Okay? So now we can actually write out our total partial sum, which is going to be 1 plus 1/2 minus 1/9 minus 1 over n plus 1. Okay, running out of room here, but that's not a big deal because all we have to do now is take our limit as n approaches infinity. Okay, we're taking a partial sum of an infinite number of terms, which is just our total sum. Okay, so this just becomes the limit as n approaches infinity of combining these two. We get 3/2 minus 1 over n minus 1 over n plus 1. Well, this will just become 0, and this will become 0, right? Because you have an n in the denominator, that will just become bigger and bigger and bigger, and that will make the whole fraction 0. So this ends up equaling 3/2. So that's about it. We started off by doing a quick partial fraction decomposition. That led us to writing out our partial fractions in our summation, which then we turned that into writing out our partial sums. And we wrote a couple terms before that actual, like, just plugging in n. Okay, so we did an n minus 1 here and an n minus 2 here, because you can see how this negative 1/3, okay, we had to wait till we got all the way over here for that actually to cancel. So it was a little more clear at that point of which ends would actually cancel. Okay? And then once we canceled everything out that needed to get canceled, we wrote out our nth partial sum. We took a limit as n approaches infinity because that's taking, basically, it's taking the sum of the whole entire infinite series. Okay? And we found that to be 3/2, which means that this series converges. Okay, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for telescoping sums, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.